Okay, Rachel, let's look at kind of a summary of what I've done so far, okay? There are 4 cases, like I've told you before, of how the parabola can face, okay? 4 cases, you know? It can face up, it can face down, it can face to the right, it can face to the left. So I've got up here 4 cases. Now, it turns out that those 4 cases, they are particular. We can identify them in terms of the general standard way of writing the equation of a parabola and whether the value of p is greater than 0 or is less than 0. So I've drawn this table for you. You should actually make a table. I think it's in your book actually. Yeah, so but it's a useful table to remember. So I've got the 2 cases of the equations on the left side here. The case where x is the one that's squared. Remember the general form, x squared equals 4py. And then the case where it's y that is squared. Y squared equals 4px. Okay? Those are the 2 forms of the equation. In the case where, remember from the beginning, where we set b and c equal to 0. Okay? Okay? Now, then you have the 2 cases where p, this special p that we've been talking about, is either greater than 0 or is less than 0. So when you have 2 things on the left that can go with 2 things at the top, how many cases do you have total? 2 by 2. 2 times 2, and you have 4 cases total. And then I've now shown how those will look graphically. You should be able to figure this out yourself by now. Okay? In fact, the last clip, I did both this and that. So the case where x squared is 4py, I've told you many times today, you look at which one is it that when it's either negative or positive, it doesn't affect the value of, it will not by itself affect the value of the other variable. So in this case, it's x. So you know, so then quickly you say, okay, so x negative, x positive, I'm still going to have the same y, depending on the value of p. So it's p positive, then it goes up. Then once you figure that part, then for that same equation, then the p negative means it will face down. Okay? And then the case where y is the one you are squaring, it means whether my y is positive or my y is negative, the x will actually keep being the same. Okay, the x will be the same, but it will depend whether p is negative or p is positive. So then I know that I'm opening facing to the right, and when p is negative, I'm facing to the left. And then the directrix, the focus, in each case, the focus has the coordinates. When it's this case, you can tell that automatically. Just remember that p has a special place in the focus. There's always going to be p. Then to remember which one, whether it's the x coordinate or the y coordinate, well, which one is the axis? The axis, along this axis, the 0 has to be the x. So the other one has to be p. Along this axis, the x has to be 0, so the y has to be p. Now in this case, the y has to be 0 because the axis is the x-axis. So the y has to be 0, so the x must be the p. Okay? And then the same thing. So just remember that in all 4 cases, the focus consists of 0 and p. And once you know that one of them will be the 0, and you can figure out which one will be the 0, then you can remember, you can figure out which one will be the p. So you don't even have to memorize this. Okay? You can sort this out, I think. And then the directrix, you know, again, you can do that automatically, right? The directrix in this case, we know it's going to be y, the same distance p as the focus from the vertex, the same distance there, so then it has to be y equals minus p, right? Because p is greater than 0, and we know this y is negative down here. So if p is greater than 0, then to make this correct, we have the negative sign. On this one, we know that along this line, y is going to be greater than 0 because this is the x-axis, right? So we're in the positive x direction. The y has to be greater than 0. So, but we know that p is less than 0. So in order for y to be positive, then it has to be negative p. So in fact, both of them will be, the line is y equals negative p for both of these. And then the case where it's y squared, y that is squared, is the line is x equals negative p. So don't even bother yourself, just know that in all cases it is negative p. Something equals negative p is in all cases. The only question is, when do you use x? When is that line x equals that negative p, or when is it y equals negative p? And you can figure that by thinking a little bit and knowing, is your directrix parallel to the x-axis, or is it parallel to the y-axis? Okay, that's what will tell you. Are you dealing with the case of y equals minus p, or are you dealing with the case of x equals minus p? So if they give you an equation and they tell you what's the equation of the directrix, okay, so just think a little bit. Which one of these cases is it facing up? Is it facing down? Look at it, inspect it, and then extract your value of p from that equation, and then that's it. Okay? You can do that. That's really the whole lecture now. Now we're going to do some exercises, okay? By